I'm delighted to welcome our second workshop presenter, Kaleigh Mentzer. I'm going to read a little bit about Kaleigh before she presents. So Kaleigh is a research engineer working on data compression and machine learning problems for Granica. She recently completed her PhD, congratulations, from ICME, Institute for Computational and Mathematical Engineering at Stanford University. She worked with Professors Irene Lowe and Professor Ataya Ashlagi. Her doctoral work focused on computational approaches to improving equitable access to education in the San Francisco Unified School District. And this project has influenced recent education policy decisions in the city. With this in mind, we're going to hear from Kaleigh related to her workshop, which is entitled Student Assignment Design and Public Sector Research Collaborations. She will take questions throughout her talk, and please submit them through the Q&A. After the talk, Kaleigh will also provide some additional resources. And with that in mind, Kaleigh, thank you so much for joining us, and let us continue. Thank you.
Good morning. Thanks so much for having me. I'm going to get my desktop shared here. As Vivera mentioned, my name is Kaleigh Mentzer. I recently finished my PhD at Stanford, and I'm currently a research engineer at a startup called Granica. But today I'm going to be talking a little bit about my dissertation work, and this is an ongoing project with a bunch of people on our team at Stanford. So I want to thank all of those people. I'll give them a little bit of a shout out later, but this is a big project. So today what I'm going to tell you about is how we've worked on student assignment design in San Francisco. So today I want to take the angle a little bit more of, how do we actually make research work in practice, as opposed to kind of digging into sort of the technical details of our work. There's a lot of things that have to happen to make something practical. So specifically what I'm going to be talking about today is, if you can see these red dots on the map, each one of those is an elementary school in San Francisco. And we're going to talk about how we assign mostly kindergartners, so like 5-year-olds, to these schools across the city. I'm hoping that today can be a bit more of a discussion. So I'm hoping to use some Slido. So if you guys who are available to join us in person today, or virtually, but live today, could go ahead and join the Slido. I'd love to be able to use that for Q&A today. And to get you guys started, I do have a quick poll to help me understand what you guys, what your background is, and how that I can hopefully try to tweak the presentation a little bit to you guys. So please go ahead. Great. So we've got a wide spread here. I hope that this presentation will be relevant to you guys regardless of your background, but I'm coming at this from the perspective of more of the academic research side, but we've had partners and collaborators coming from the public sector side as well. And great. So if you guys have Slido open, there's also a Q&A option. So we'll keep that live throughout, and you guys can vote on each other's questions, and we can take those questions as we go. I will quickly throw the Slido link in the chat. It's for anyone who missed it. Oops, sorry, that was just for panelists. Great. Let's get started. Okay, so the first question I want to ask you guys is, how were you assigned to kindergarten? Probably not something that you've thought about very much, but it probably affected a lot of things about your childhood. It probably shaped your mornings, your commutes to school. It probably affected who your friends were growing up. And more broadly, when these things happen at an aggregate level, they affect things like traffic patterns, congestion, school segregation, many different facts that ended up that ended up deciding what does your community look like. So one of the ways that we're most commonly thought of as assigning students to schools is neighborhood assignment. So you live in a particular neighborhood, you just go to the closest school. And this can be great for a lot of reasons. You get to go to school close to home by definition, at least ideally. And it's a simple system to decide who goes to what school. One potential downside that you have in this setting is that if neighborhoods are segregated, then schools are also segregated. This could be socioeconomically, racially, on many different dimensions. We might have residential segregation that's reflected in schools. So one thing that many large school districts, particularly in the US, have looked at is trying to decouple neighborhood segregation and school segregation. And the way that many of these schools do this is they have a centralized matching system where students get to choose from any schools in the city, so citywide choice. And families usually submit a rank order preference list. We'll talk a little bit more about the mechanics of this in a moment. And then there's the centralized matching algorithm that assigns students to schools. And the idea is, if you don't like your neighborhood school, you have more options outside of that. So this is potentially giving students the opportunity to access more schools and potentially decouple this residential segregation and school segregation. However, I want to highlight that this is not necessarily a perfect solution. If students or families tend to choose schools in such a way that self-segregate, you might still get segregation in schools. And this doesn't necessarily have to be it doesn't have to be, it can be like pretty benign in the sense that like maybe you want to go to school close to home. So you can still have ways that families choose that lead to segregated schools as well. So digging into a little bit of how this actually works, this is the citywide choice system is what's currently implemented in San Francisco. So we have a handful of families and they're going to submit a rank order preference list. So what that means is you get to look at all there's 72 different elementary schools in San Francisco, and they can rank their first choice, their second choice, their third choice, and so on. Then they'll submit that preference list to the district, and this district will run a centralized matching algorithm. I won't go too much into the details of this, but essentially it takes the students' preferences and it takes some school district level priorities, like for example, being able to send students with older siblings to those schools, they get higher priority for those schools. And the result is we get an assignment of students to schools. And there's a lot of things that we can do with this matching algorithm by tweaking these priorities. And I'll talk a little bit more about this, but there's things we can change about this to try to achieve different distributional outcomes when we look at the actual schools. So mostly I'll be talking today about San Francisco. So to give a little bit of context, we're talking about the San Francisco Unified School District, which includes all of the city of San Francisco. It's abbreviated SFUSD, so if I mention that, that's what I mean. It currently serves about 51,000 students, and a little over half of them are eligible for free or reduced price meals. This is generally a proxy for lower socioeconomic status, and we'll use that as a measure for socioeconomic status in today's presentation. Each year, there's about 5,000 applicants for kindergarten each year, and we're going to try to assign those students to one of 72 different elementary schools. There's also a number of other complicating factors here. So SFUSD offers many different language programs. So within those 72 different schools, there's actually about 150 different sub-programs total. And this includes things like special education, language program, language immersion for non-native speakers, and then there's also programs for English language learners as well. So an important piece of context here is that San Francisco has very entrenched residential segregation patterns. So here we have a redlining map from 1937. So the areas you see in red here were systematically denied access to financial tools such as home loans. And this is generally considered a form of geographic discrimination. And so those areas, particularly the areas in red that were systematically denied access to these types of tools, often are, less socioeconomically advantaged because of this discrimination. And if we look at a free and reduced price lunch eligibility map from 2020, so this is another proxy for low socioeconomic status, we see that the yellow dots, the students who are eligible for these reduced price meals or free meals, still map very closely to those areas that were redlined back in 1937. So even though it's been more than 80 years, we still see the effects of some of these spatial discrimination patterns that lead to pretty stark patterns that we still see today. And I will also mention that San Francisco is also fairly racially segregated as well. And this can just add to the additional challenges. So despite the citywide choice program that I mentioned that San Francisco has been using, schools are still socioeconomically and racially segregated. So here, the redder regions are the neighborhoods with the background map is the eligibility for free or reduced price meals. And then the darker red dots are the schools with the highest percentage of free or reduced price meal eligible students. So we see that the neighborhoods that have higher eligibility still have schools that have higher eligibility. So the more socioeconomically disadvantaged schools or neighborhoods also have socioeconomically disadvantaged schools. So this kind of indicates that we potentially have not been able to disrupt this coupling between neighborhood socioeconomic status and school socioeconomic status. We can also look at this from a different perspective, from the racial perspective. And here we're looking at the district's definition of historically underserved ethnic groups. And again, we see that neighborhoods with the highest percentage of students from historically underserved ethnic groups also have schools that are from those groups. So we're not, despite this option to have citywide choice that you can choose from any school in the district, there's still this pretty tight coupling between where you live and where you go to school. So our hopes for what citywide choice can do to improve school diversity is not really coming to fruition in practice. So this is a very nuanced issue, but broadly speaking, what the education literature says is that segregation that's reflected in schools can indicate potential problems for students. So there's a fair amount of research here, and in broad strokes, as school segregation increases, we typically see that the racial achievement gap tends to increase. So more segregation is associated with greater disparity between different ethnic groups, which is bad for students. And similarly, there's been a fair amount of research on desegregation efforts in the South. This includes things like court-ordered desegregation, busing, these types of things. And these studies provide, or these case studies essentially, provide some evidence for that desegregation improves health, graduation rates, future income for Black students. And so in general, we think that having more diverse schools is good for students in broad strokes. So what does this mean for our participation? So SFUSD initiated a redesign of their student assignment algorithms. And they, in 2018, they passed a board resolution to redesign how they assign students to elementary schools. So this is sort of what kicked off this initial process of how do we actually go through and redesign how we assign students to schools from their current system of this, you can choose anything within the city. And this process had 3 different goals. The first is diversity. So the goal here was to have schools that were socioeconomically and racially representative of the district as a whole. And the second was predictability. This is much more focused on sort of the qualitative experience that families have, that currently could be assigned to any school in the district. So you could be like you could live in one side of the city and be assigned to the other side, even if you didn't rank it, just because there wasn't enough space in the schools near you. So these kinds of things do happen. So there was this goal to have a more predictable system where families could kind of have a good guess of where they might be assigned. And then another factor here is proximity. So there's many reasons why we might want to have families going to school relatively close to home. First of all, like travel times. As I mentioned, under the current system, there are some families that are making really long commutes. Another factor here is that due to budget constraints, there's not necessarily like public school buses available to all families. In fact, the majority of families in general education programs in particular have to find their own way to school. So this is a particular concern, is if you don't have the budget to bus students to schools that they're assigned to far from home, you kind of have to want to assign students to school close to home to relieve that burden of commuting. Another factor here is community cohesion. In many cases, schools can be a center for a lot of social support. So that being able to have to go to school with your neighbors can lead to a lot of different pro-social community building, as well as, better support systems for families in need. So here I want to take a moment and to provide a little bit of advice on this collaboration aspects, is that at the beginning of a project, it's really important to agree on the objectives and definitions. So at the very beginning of a project, you really want to make sure that you have your objectives clearly and ideally quantified or quantitatively defined at the outset. So if we look at these goals, diversity, proximity, and predictability, what do those actually mean in terms of metrics? There's many different ways you can measure diversity. There's many different dimensions that you might want to measure. How do you actually capture those? How do you tell if you're doing better on those things? These are really difficult questions. And it's something that, no one wants to have to make a decision about what these specific goals are, because, there's trade-offs. Some measures are going to be good at some things, but they will also have certain shortcomings. But in order for a good collaboration, it's pretty important to kind of nail down what these goals are at the outset. You can always go back and revisit them, but agree on what success looks like. We in particular have had difficulty measuring predictability because it's more of like an individual experience. Like, what does this actually mean for families to feel like they had a more predictable student assignment system? It's kind of difficult to tell. So one of the things you have to do at the beginning of these types of collaborations is come up with some sort of measure. And, not everything is going to be captured with a number, absolutely. But in order to kind of progress or to make steps forward, sometimes you need to come up with some sort of agreed definition. So at the beginning of this collaboration, the district defined some goals, and then we spoke to them, and they had some initial ideas for how they might achieve these goals. So they proposed 3 initial concepts. The first being concept 1. So this is an idea where you'd automatically be assigned to your neighborhood school. And then there'd be this kind of optional opt-in choice process where you could go through the current process and rank any school in the district and be assigned there. But if you didn't want to do that, you could just automatically be assigned to your neighborhood school. I won't talk too much about this particular policy moving forward. We ran some initial simulations with this, and it doesn't change the school diversity that much, and that was an important goal for the district. So we didn't end up exploring this option too far moving forward, just based on these preliminary results. The second concept was smaller zones. So you would have a zone with about 3 to 5 schools in it, and that you would have access to those schools within your zone. And then you would also have access to these special citywide programs, which many of them include language programs, There's some K-8 schools, other kind of exceptions to schools that are not neighborhood schools, that you would still have access to those outside of your zone if you so desired. And then the third concept was larger zones. So these would be, I forget the exact number, but let's say like 8 to 10 schools in each zone. And you would have all of your choice restricted within this zone. So there would be, all of your options would be within your geographic zone. And then these special citywide programs that I mentioned would be divvied up amongst the zones in order to make sure that families still retain access to all of the different programs that they had initially. So, you're not going to, by creating these zones, you're not going to take options away from families, maybe specific schools, but any type of language programs, special education programs, families would all retain access to those types of programs. So another kind of meta advice here. So you want to try not to get locked in to how your collaborators are thinking about a problem or a solution. You have a skill set as a data scientist or whatever your skill set may be that you were probably brought into this collaboration because you have a different skill set than the stakeholders. So their perspective on this problem is shaped by very important aspects, such as like being more in touch with this particular community that you're working with, being much more familiar with kind of the education space in general. And you have a different skill set. So in our case, we were much more, we had, deep technical expertise and specific matching algorithms and stuff like that. And both of you have different perspectives, and that may be a good thing. So you may have some ideas that might be different than what the district was expecting. And that doesn't necessarily, they might not work, but it's a good idea to bring them up because they might not have considered the perspective that you have or the type of tools that you have. So don't be afraid to suggest solutions or alternative approaches when you have the opportunity to. So taking our own advice to heart, I mentioned that we have this student assignment algorithm we saw before, where families are going to rank schools. They're going to submit those to the district. It's going to run a matching algorithm, variant of Gail Shapley's deferred acceptance algorithm, and assign students to schools. And this problem has actually been fairly well studied in a field of operations research that's generally called school choice, and that can mean different things to different people. But in this case, we mean how we do this centralized matching system where families get to express preferences over schools. So some of the ways that the school choice literature suggests that we can impact this process is first, we can provide what's called menus. So instead of giving families access to all of the schools, we can give them access to a specific subset. And obviously that's going to have an impact on the final assignment if you're restricting the choices that families have. And the general idea is that this can potentially impact diversity if you are, for example, oops, that's not good. My camera battery is dying. One moment.
Just to highlight while we're waiting, there's some interesting commentary in the chat from a few of the attendees related to this topic. And also keep in mind, there should be some time for some questions towards the end. So, okay, we're back.
Sorry about that. I thought it was plugged in, but apparently that outlet doesn't work.
Okay. No worries.
So the general idea here is that if you, we mentioned earlier with the citywide choice system that the way families choose can impact how schools are segregated. And the idea is that like, if you restrict the choices, you might be able to kind of limit the extent to which choice-driven segregation impacts schools. So this is one potential tool that we can use to impact these types of outcomes. Another one is priorities. So I mentioned that these algorithms are kind of two-sided matching algorithms. So we take into account the preferences that families have, but there's also this kind of school side preferences in the sense of like, okay, we would like students to be able to go to school with their siblings if they want to. There's other potential priorities that are used in these matching algorithms. The current ones that are used by the district are a sibling tiebreaker, a equity tiebreaker for students coming from historically academically low performing neighborhoods, and a neighborhood tiebreaker, so you have higher priority to go through your neighborhood school. These aren't guarantees, but these just help the algorithm decide if a school is oversubscribed, who do you give your seats to first? Another system, and this that you can use to modify this matching algorithm, is ideas such as quotas and reserves. So this can also mean different things in different contexts. But what I mean here is going to be setting aside seats typically for underserved groups. And so in some cases, these are generally minimums. So you want to have a certain number of students be able to access every school. And they're often, in the cases that we're going to talk about today, can be soft reserved. So for example, if a student who has a seat set aside for them doesn't want it, no one who is eligible for it specifically wants it, someone else can have it as well outside of that group. So there's many different tweaks you can make to this, but these are some of the tools that are available to us as algorithm designers to be able to decide what those, or to impact what the final assignment of students to schools looks like. Okay, so we have all of these ideas, we have some of these tools. What we did as researchers at this point was start to build some sample policies. And I'm going to show you 3 here. We looked at many policies. These are not even representative of all of the types of policies we looked at, but these are a couple ones that represent some of those tools that I just mentioned that the school choice literature suggests, combined with some of these ideas that SFUSD had and trying to kind of fuse them into some potential policies. So the first is similar to these, concept 1 or concept 2 and concept 3 that the district proposed. We're going to have students choose from one of 9 contiguous zones based on their neighborhood, and that they would be able to choose from schools within that neighborhood. This is not a candidate map at all. This is just, so I just want to clarify that, no maps are like real here. But this was a map that we picked out because it seemed to perform well on different representative diversity measures that we discussed before. Our second policy was a zones plus reserves policy. So this was adding on to the zones policy. When we're assigning students to schools, we're going to set aside seats for disadvantaged students. And again, these are kind of soft reserves. So anyone can take those seats if they're under demanded. The final policy that I'll show you today is a 3 priority group policy. So we used a composite diversity measure to create 3 equal sized groups, and the lowest tercile would have the first choice to all of these schools, then the middle tercile, and then the top tercile. And these were based on geographic proxies because we're not allowed to use individual student characteristics for this type of assignment algorithm. So yeah, this was sort of based on how can we just manipulate the priorities the district uses in order to try to achieve the distributional outcomes that we're looking at. So in order to test these policies, we built a very large simulation engine. So this is probably like one of the bigger technical chunks that we had to deal with. So basically we had this, we can simulate the student assignment algorithm, but it's a little bit more complicated than that. We can also need to determine our zones, reserves, and priorities, and those are all going to be based on different policy decisions that we can set inside this algorithm. Then another factor is we have to think about how we're modeling student families' preferences, because in practice, most families only rank a few programs. So this can be a problem if we're changing the options that are available to families. Say we're doing some sort of small zone and there's only 3 to 5 programs in their zone. They might not have actually ranked any of these programs in terms of the historical data. So we need a way to be able to investigate these counterfactual scenarios and come up with what we anticipate their ranking would have been if these were the options that were available to them. So the way we do this is with a discrete choice model. We're particularly using a multinomial logit choice model. But basically, this just gives us a way to model how families choose schools entirely in a predictive way. We're not trying to explain why families choose, why we're not trying to get any sort of causality here, is I guess what I'm trying to say. So once we are able to set our policy, we set how we predict families' preferences, and then we can actually generate these assignments of students to schools, and we can calculate metrics, generally a suite of metrics, because as I mentioned, there's kind of shortcomings to each of them. We also created a bunch of visualization tools to help less technical stakeholders engage with these simulation results, with these metrics, and to get an idea of what potential policies mean for schools, and how well each potential policy is performing with respect to the district goals. One quick thing, and then I will hop over to Q&A for a moment. This is, benign advice to some extent, but I think it's really important. And when you're collaborating with somebody, you're rarely going to use code just once. So I would really, really highly recommend maintaining sort of production quality modular code. And there's a few reasons for this. The first is you're going to have to iterate on your solutions. You're going to talk with your stakeholders, realize you want to try something else. They'll have ideas of oh, what if we tried this? You want to be able to have your code adapt to be able to answer those questions and be more dynamic in terms of how you're able to collaborate with your partners. So I would really recommend saving yourself the future headache to avoid, kind of hard coding quick fixes, try things. And in particular in this space, reproducibility is really important. So if you're going to be influencing real world policy, you want to be able to reproduce your results and make sure they're correct. So things like making sure that you're not, leaving things hard coded is really important. There is an upfront cost to maintaining this type of thing, but I really think it's worth it. Yes, that's my 2 cents there. So let's go to Q&A. Okay. This is responses there. If we don't have too many questions right now, then maybe we'll do a larger Q&A at the end, and we'll make sure to leave some time for that as well.
Yeah, so in the Q&A panel, I can assist with that. So if you have more to present, Kaleigh, please feel free to do so, and then we can return to the panel.
Sure, yeah, we'll come back to that. So what did this actually look like? This is a very simplified view of our findings, but we looked at a bunch of different predictability, proximity, all these different measures, and we looked at these different policies, and this rightmost column represents the actual assignment algorithm that was used for the 2018-2019 school year. So this is sort of a benchmark for the current policy. And the first thing I want to note is that, first, there were 3 district goals: proximity, predictability, and diversity. However, there's 4 columns here, and one of them is choice. So this is essentially how many students are getting one of their top 3 choices or something like that. And this was not explicitly a district goal, but one thing, it is important that we want to keep an eye on this, because if families are used to getting one of their top 5 choices, for example, and they're no longer getting that might be a good proxy for sort of dissatisfaction with the student assignment process. And this can be a problem for many different reasons. We generally want to keep these families happy, be able to send them to schools that they want to go to. Again, this wasn't a district goal. So, for example, achieving diverse schools was more important than making sure that families get their top choice. But this is an important thing to keep an eye on. So the first thing I want to note when you look at this result is that no column is entirely green. So what this means is we can't have all of these goals, at least in the space of policies that we've explored so far. And it is, there are trade-offs that we have to deal with in this system. So for example, we saw that neighborhoods are segregated. It's very difficult to have diverse schools and have students go to school close to home. So there are these tensions between different goals that are kind of a result of parameters of the system that we can't exactly change within the student assignment algorithm itself. So there are different trade-offs we have to have here. We can see that the zones plus reserves policy here does pretty well on the district goals. So proximity, predictability, and diversity, but it doesn't do as well on choice. So there are these sorts of trade-offs. But this is the policy that kind of most closely aligns with the district goals as defined in the redesign. So this is generally where you'd stop kind of the academic presentation to some extent, that you've developed some policy ideas, simulated them, saw what the results are. But I want to give you a little bit of an idea of how this collaboration actually worked in practice. So initially we received some raw data. Those are the historical preference lists that were submitted by families. So we can help start to understand what does the current assignment look like, and how do families choose schools historically. We had weekly meetings with the district staff to discuss our research findings and make sure that we're kind of aligned moving through this process. And then in the fall of 2020, we were able to present our work to the SFUSD Board of Education to give them an idea of what our findings were, basically what I just showed you guys, and what the trade-offs are that we have to face in this process. And once we did that, the policy kind of continued to develop a little bit less with our expertise. So the district staff developed a policy recommendation that was informed by the trade-offs that we explored. And they proposed this policy to the Board of Education. And then finally, the Board of Education would vote on this policy and decide if they wanted to go into effect. And so what actually happened is the board did end up approving some guidelines based on our policy. So this is not a full-fledged student assignment policy, but it's specifying what this new policy will look like moving forward. So what specifically this was is that the guideline was to develop a zones plus reserves type policy, not specifically this zones plus reserves policy that we simulated, but something similar to that. And there was the mandate that zones have to be within 15% of the district average in terms of free or reduced price lunch eligibility. So this is, again, trying to make sure that zones are about socioeconomically, they're not too far from the district average in terms of socioeconomic status. There was a lot still to be determined at this point. So no zones have been selected. The specific reserve structure we talked about has not been determined. They're looking at a different equity priority to help students experiencing homelessness and other students in foster care. So there's a lot that still needs to be decided here. And the initial timeline to implement this was to be for this school year that's starting right now. But I want to highlight that, this seems like the end. We got our policy approved, but this is, we probably did less than a third of the work for this project. We still need to determine a lot of different things that are sometimes swept under the rug as like implementation details. And there's still there's a lot of legwork to be done to actually make things happen in practice. One thing I do want to highlight is that success may be a moving target. The education system is extremely complicated. So as a researcher or as a collaborator, you have to be flexible. Goals may change, timelines get pushed back, and the current plan for this is to be implemented for the 2026-2027 academic year. There have been delays and changes in the objectives, and this is not necessarily entirely a bad thing. As we move forward towards implementation, we're learning more and having more time to be able to adapt our policy to really meet the needs of families is really important. One small plug that I would make, if any of you are academic advisors, is to try not to have your students' graduation depend on implementation if possible, because that can be a very challenging situation for grad students to be in. But I do want to highlight that you have to be prepared to pivot. So you can't get too attached to your research. You might be able to find a really cool finding that works really well, but you have to be able to put that aside and say, if this is not actually going to meet the needs of our stakeholders, we can't move forward with it, at least in terms of application. You might still be able to write a paper about your findings, but you have to be ready to adapt as situations change. And that can be challenging from an ego perspective as a researcher, but it's very important to make sure that you're meeting the needs of your stakeholders to actually have something that works in practice. So one thing I want to kind of dive into as an example of what makes for good zones. So this is an example of one of the sort of implementation details that what does this actually look like moving forward. So we mentioned that we have zones. These are going to affect student assignments by restricting the options that are available to families. So the student who lives in this pink zone, we get to choose between the pink schools, plus some additional language and special education programs outside of that zone. There's a lot of things that we need for these zones to work. So the first is that we need to actually have enough school capacity for students in each of these zones. We also want to make sure that families have about the same number of options, sort of like a fairness thing. You want to let people choose from the same number of schools. If you have 10 options and your neighbor has 3, it might not seem fair. There's also the socioeconomic status and racial diversity goal of trying to have each district or each zone be fairly representative of the district as a whole. You might want to have, similar types of school options between each zone. So this might be, different type. There's many different measures that you might be interested in here. Distance, so I mentioned, transportation isn't necessarily provided for families, so you want to make sure that the zone isn't too long. You're still going to be assigned to school close to home. And then this sort of continuity and compactness. You want zones that kind of look reasonable, and there's many reasons that this is important. One of them is sort of this, is it easy to communicate? If you're looking at a map, is it easy to tell where one zone begins and one ends? And it might seem sort of arbitrary if your neighbor, if you're right next to each other, but you have totally different school options. So these are kind of some of the factors that we were thinking about in designing zones. So this is actually, it turns out, a very computationally hard optimization problem to try to solve all these things simultaneously. So our first step was to try to encode all of these requirements in math as an integer program. So we're generally trying to maximize desirable zone characteristics subject to having some form of operationally viable zones. So we produced some zones through this, and then we showed them to stakeholders to elicit feedback. And this could be in the form of new constraints that we missed before, but actually are necessary in order to have viable zones, or potentially updating new or old constraints that weren't necessarily meeting the objectives of the initial district. And this is generally kind of an over-constrained problem. So we have to relax some things. As I mentioned, you can't have everything, or at least our research suggests that. So we actually iterate on this process many times. We update our model and kind of go back and forth because we as researchers speak math, and the district stakeholders speak what the families need, and that translation sometimes takes multiple attempts. So after we kind of did several iterations of this with our close collaborators, we were able to do some focus groups to show maps to community members to get additional perspectives. First, one type of feedback we got was kind of these tensions between these decisions, that there might be like value judgments. So for example, there's some question about whether or not we should split up cultural neighborhoods. If we don't split up the neighborhoods, then there are some, it might be harder to achieve specific diversity goals. But on the other hand, these are cohesive communities, and maybe we want them to allow families to go to school together. Other types of feedbacks were like things that are pretty easy, concrete. So like Golden Gate Park is a large park in San Francisco. It's difficult to cross during rush hour because there's only like a few roads that cross it. So one of the recommendations we got is, don't have zones that make people commute across Golden Gate Park. And finally, we also got some kind of process engagement for how we talk to families and how we can improve that process. So for example, people wanted to see where the public transit routes with respect to these zones. And one of the things that we saw a couple of times in these focus groups was that families would actually or stakeholders would take pens and kind of draw their own zones on top of the zones we had. And this sort of inspired us to build this tool to help families engage a little bit more. So I'll show you guys what this looks like here. To let families draw their own zones and get sort of live feedback that as they change these zones, the table you'll see will give you some idea of what how that changes the demographics of each zone. Let people try out their ideas and see where the trade-offs exist. It also would allow you to look at different overlays on top of this. So this is the idea here, was to be let people be a little bit more involved in a hands-on way with the zone design process. And this could be used to help families understand this problem. It's pretty difficult to kind of conceptualize a lot of these zone questions, but also to elicit specific feedback and new constraints. So I'm just about to wrap up here. I want to let you know what the current status of this project is. So as I mentioned, they're currently aiming for implementation for the 2026-2027 school year. So it's been pushed back a couple of times. Some of this is, COVID impacted some things. There's a number of different policies or things that are kind of outside of our control that have impacted the way the new policy. So this has given us some more time to dig into some of the research, but things have been delayed. And we're continuing to learn about this zone design process and the needs and preferences of families. And then finally, we've been continually adapting to this dynamic environment. So there's a few different things here. Public transit routes change over time. There are new housing developments that change where families live in the city. The demographic shifts over time. All of these things mean we need to be able to update our zones or any type of geographic proxy we're using to kind of adapt to this dynamic system. There's a lot of things that go on in practice, so you have to make sure that you're kind of up to date on all of these things. It's definitely not a one and done type of project. I do want to take the last moment here to thank some of the people who have been involved in this project. There's too many to mention, but here are some that have been very involved with this project. Our team at Stanford, and we've had some really wonderful collaborators at SFUSD. A lot of people who put their work into this project. Just a huge thank you to them, and they get most of the credit for this project. With that, I'd like to transition over to Q&A. Well, thank you all for your time, and please feel free to reach out with questions if we're not able to address those in the time we have left.
This is great. Thank you, Kaleigh, so much for sharing this information with us. And we do have quite a few questions in the Q&A panel. So just to set expectations, in the remaining 11 minutes that we have, we'll try to answer as many of these questions during this time. But if there are any remaining questions, we could continue answering them offline in that Q&A panel or otherwise. So here is the first question. So one of the first questions was, were these measures collaborated with community groups and families?
Yes, so there have been, we did attend some community engagement events, and these are mostly like run by the school district, and we kind of sit in on. Some of this was made more challenging by the fact that most of these initial decisions happened during 2020. So it was more difficult to do this kind of community engagement. But it was definitely a group effort. We also collaborated with some education researchers who have some ideas of how specific measures map to the education research in terms of being predictive of student outcomes. So trying to really get all of the sort of academic gains we can out of these measures as well.
And this is very interesting because when it comes to certain topics, there's the idea that representation matters. And
Mhm.
the community involvement is one aspect. I'm curious, was there any representation from the community on the research team directly, like any people who were students or researchers?
Yeah, so our team was primarily, our Stanford researchers and the staff that we worked with here. We definitely tried to um, get involved with engagement as much as possible. It's been a little bit difficult given some of the other events happening within the school district of itself. That's something we would, like to improve more of moving forward. But it is challenging, but I agree that it's very important to have the most effective outcomes.
Thank you, Kaleigh. And here's the next question. How do you stop the Hunger Games or gamification of the algorithms used?
Yeah, so this is a big idea in this sort of operations research literature is that we think about this as sort of a game theory type of question, actually. So one of the things that we look for in these algorithms that we uh, is this sense of strategy proofness that you can't improve your outcomes by like misreporting your preferences. So that's one way that we try to kind of avoid this misreporting and attempt to game the system. So you can't really game the system ideally. There are other types of things that happen, like address fraud, where you might pretend like you live in a neighborhood that gets this academic priority. So there's actually some ongoing research about, how can you design systems to kind of be resilient to these types of perturbations to the system. But it is a difficult question, but generally we try to look for these strategy proof algorithms.
And that definitely makes sense. And let's continue with the next question. I'm trying to monitor both the Q&A panel and the chat, but we'll stay with the Q&A panel for now. The next question is, was your team approached with this problem? Who spoke to the stakeholders and what roles did the individual members take?
Yes, so some of this happened before I was involved with the project. I kind of came in when we got the data, but to the extent that I'm aware of, some of the PIs in our group, the professors, had prior experience with redesigning student assignment in other cities. So there had been sort of this discussion. I think, SFUSD in general has extensive collaborations with Stanford, with various other schools in California, and they have really robust researcher collaboration. So there sort of was already the infrastructure for this, and then there's sort of this overlap in expertise as well. So I think mostly this was determined by district staff and the researchers as well. Yeah.
And just to also highlight, Kaleigh, thank you for that reply. And this research is continuing because you noted that,
Yes.
the release of this work isn't for a few years. So there's going to be some potential additional collaborators and researchers as well.
Yes, and this next phase moving forward is really more heavily focused on getting more parent voices, more community members involved in this discussion.
Thank you. And there is a question before this one, but I'll shift to this one and then hopefully go back to the next. So one question is, can we see some of the code or models used for this analysis?
I hope so at some point. As of right now, these are not publicly available. We are working on the process of trying to make these tools more general so that as we mentioned, we put a lot of effort into building these simulation tools. Other districts face similar problems, so we're really working on trying to package up this work into something that's usable for other districts as well. So we're kind of holding off on showing our code until that point, but stay tuned.
Absolutely. And, just to highlight too, there are other related resources that Kaleigh will share after, just not the code at this point in
Yes.
time and or the underlying analysis. Okay.
Correct.
And looking at kind of the theme of going future forward. So we have the following comment/question. So the person missed the beginning of the talk and they'll see it on the recording. I know they will. But their question is, how did you get involved with this project? The person is a college student with interest in applied math and education. So they'd love to hear from you and get your expertise on getting involved with this type of project. Do you know of any similar opportunities that you could point this person to, and or some skills that would be useful to acquire? I know it's a lengthy question, but any initial thoughts?
Yeah, so I think my personal engagement or involvement with this project was very serendipitous. Like I was, starting a PhD program right when this was starting, so I got very lucky in that respect. But I think there are generally collaborations within school districts that if you can look for what's already happening there, you might be able to get your foot in the door with some of these collaborations. So one place to look is board meeting notes or meetings. These are generally speaking public meetings. They're generally recorded, available online, so you can see kind of what school districts are thinking about right now, what their priorities are. Your results, your mileage may vary when it comes to like how open districts are to collaboration. In general, like we're not getting paid for this work. This is a mutually beneficial collaboration in the sense of like we get to do some interesting academic research, and as a result we get to help kind of consult, if you will, for the district. But this does take bandwidth. We've had collaborators who are spending a lot of time, investing a lot of time in meetings with us, and that might not always be reasonable to ask from districts depending on their kind of bandwidth for these types of things. So you do have to be a little bit conscientious. So if those collaborations already exist, that's a great place to start.
And that's great. This is a very helpful starting point, I think, for not just that one person, but quite a few of the audience members. And once again, thinking about this theme of going future forward. So next question is, and this is probably the last question, are you able to or expected to deliver an algorithm that could be used by the city in the future to accommodate for population changes, transit changes, and other similar changes?
Yeah, so this is not something that I had the chance to mention, but in the policy guidelines that were passed or that voted on by the board, there's actually a provision that these zones will be updated on a regular basis. And our research, we kind of have to figure out how we're drawing zones the first time, but once we figure that out, we do anticipate trying to, come up with a system for how these zones might be revised over time, because generally changing geographic boundaries is it's a difficult problem, and it's often a very political one. So being able to make sure that you have a system in place and a plan is very important. We don't know what that looks like yet, but yes, we are trying to make sure that our whatever policy ends up being implemented is robust to these future changes.
And that definitely makes a lot of sense. And I know time-wise, we're almost at time. So I'll continue with saying, thank you, Kaleigh, for your presentation. I saw a lot of great comments, not just in the Q&A panel, but also in the chat. So a lot of people appreciated your talk. There are a few questions remaining in the Q&A. So offline, you can decide to answer them in the Q&A panel or otherwise.
Respond to them shortly.
Great. Thank you so much, Kaleigh. And by the way, I just want to call out, she does have her contact information on her final slide. So she does have her handle via Twitter. So that seems to be a pathway to continue to connect with Kaleigh. And there may be some other information shared in the chat, but definitely after the presentation as well. So thank you once again, Kaleigh.
Thank you so much
for sharing your expertise
Happy
with us today.
Continue the conversation.
Awesome. Sounds like a plan.